So hello everyone and welcome back to a brand new video, and in this video I'll be solving problem D, that is counting arrays from Edu round 138. But before we start with the video, I recently posted on LinkedIn about my recent internship opportunity. I will leave a link to the post down below, so please head over to that link and show some love on the post. I will highly appreciate that. Yeah, so that was it for the promos, and let's start with the video now. Before we move on to the solution, I want to take a small break and tell you guys about Newton School's Premier Coding Contest. So as all of you guys love CP and all of you guys love to code, this is a great opportunity to show off your coding skills and also win some cash prizes. There are prizes worth rupees 30,000, and along with this you can also win some free coding courses or also grab some internship opportunities. Right, so for this reason only, Newton School organizes this contest every month on a global scale. So you can also benchmark yourself where you are lacking or where you are standing compared to other students. So this month it will be on 27th October. It will be around 2.5 hours starting from 9 p.m. and it is absolutely free to sign up for. So there will be a link down below. So do check out that link and sign up for the contest for absolutely free. Yeah. So let's move on to the solution now. So in the problem, we are basically dealing with arrays. So we either call an array ambiguous or either we call it unambiguous. Now, how do we bifurcate them? So to bifurcate them, let's take an example. Let's say we have an array A of size n. So something like A1, A2, A3, so on up to An. Then we can choose any element AI in the array such that GCD of AI comma I is equal to 1 and then remove AI. Right, so that is the operation. So in one operation we can choose any element AI in the array such that GCD of AI comma I is equal to 1 and remove AI. We also define something called a removal sequence. Let's say we show it using array B, right? So when we remove the element at index I, when we remove AI, we will push index I into array B. So when I remove AI, my new array B will be I. Similarly, if I remove some element AJ, then I will also push J to my array B. So now my new array will be I comma J. And if I remove some element K now, my new array B will be how much? It will be I, J, K, right? So that's how in every operation, I will remove some element and push its index into my removal sequence B. If for some array A, there are multiple, or you can say if there are more than one. If there are more than one possible removal sequences, we call it ambiguous array. Right? And if the array is not ambiguous, that is if array A has only one possible removal sequence, then we call it unambiguous. For example, let's say your array A is equal to 1 and 5. 1 and 5. Not 1 and 5. Let's say your array A is equal to 1 and 2. Right? Then the only possible removal sequences, you first have to remove the first element. Right? So your B will have 1. Then your new array A will be 2. Right? So then you will remove 2 and you will again insert 1. So the only possible removal sequence is B equal to 1, 1. But if we take, let's say, example of A is equal to 1 comma 5, here we can first remove the first element. So my B will be 1 and I will remove the 1. So my A will be equal to 5. Now I can again remove 5 and now my B will be again 1, 1. But in this case, I can also remove 5 first. So if I have A equal to 1 comma 5, I can first also remove 5. So in this case, my B will be 2 comma 1, right? As you can see, for A equal to 1 comma 5, I have two possible sequences. I have B equal to 1, 1 and I have B equal to 2, 1, right? So the array A equal to 1, 5 is ambiguous. And array A equal to 1, 2 has only one possible removal sequence. So my array A equal to 1, 2 is unambiguous. I hope the problem is clear now, right? So given this, we have been given two integers. n and m, and for every length 1 to n, we have to find sum of all possible ambiguous arrays. Ambiguous arrays where element ai can be from 1 to m. So that is the problem. So given two integers n and m, we have to find the sum of all possible ambiguous arrays from length 1 to n, right? So for every possible length from 1 to n, we have to find the sum of all possible ambiguous arrays where your array elements ai can be from 1 and up to m. So that is the problem. So how can we solve this? So let's move on to the observations. So the very first thing that we will do is, instead of finding the number of ambiguous arrays, we will instead find number of unambiguous arrays, right? And as there are only two possible ways, either an array is ambiguous or either an array is unambiguous. So we can say that number of ambiguous arrays is equal to total number of possible arrays, minus number of unambiguous arrays. Total number of arrays are easy to compute, and if we can somehow find a number of, it will be unambiguous arrays. So if we can somehow find number of unambiguous arrays, we can compute the number of ambiguous arrays. This is what we want, right? This is the answer that we require. This is easy to compute. Now we just need to find number of unambiguous arrays for every length from 1 to n, right? So how can we do this? Let's see. Also, the total number of possible arrays are how much? For length 1, possible number of possible arrays, are equal to just m, right? Because you can use all the values from 1 to m in the first index. For length 2, it will be how much? It will be m into m, right? You can use m values for the first index and m value for the second index. Similarly, for length 3, it will be m into m, that is equal to m cube. So at length n, it will be m the power n. So if you try to find sum of total possible, or you can say total possible arrays is equal to how much? It will just be m plus m square plus m cube, so on up to m the power n. This is just a GP, and sum of this GP is how much? Sum of the GP is m into m the power n minus 1 over m minus 1, right? So that is the total possible arrays. So we can just use this value here, right? So total number of arrays are how much? It is m into m the power n minus 1 over m minus 1. Now we just need to compute number of unambiguous arrays. So how can we do that? Let's see. So let's move on to observation 2. That is, all arrays have a removal sequence. All arrays have a removal sequence of all ones, right? Let's say we have array a1, a2, a3, so on up to an. So what we can do is, we can always use the first element, right? Because on the first element, I is equal to 1 and GCD of anything, comma 1 is equal to 1, right? So we can always choose the element that is on the first index and remove it. So my B will be equal to 1. Again, now my A2 is the first element, so now I can remove A2 in the same way. So now my B is equal to 1, comma 1. So I can keep doing the same thing until I remove all the elements. right? So in the end, my b will be how much? It will be just 1 1 1 1 so on, right? So it will just be a series of all ones. So all the arrays will have a removal sequence that is made up of all ones. So all the arrays will have a removal sequence that is made up of all ones. But in unambiguous arrays, it is only allowed to have one possible removal sequence, right? Unambiguous arrays must have only one possible removal sequence. So the only possible removal sequence for unambiguous arrays is all ones, right? So for unambiguous arrays, only possible removal sequence is of all ones, right? It should not have any other removal sequence. So we will take benefit of this fact and use this to count the number of unambiguous arrays. How so? So let's move on to observation 3. Using what we just saw, that an unambiguous array should only have just one removal sequence that is made up of all ones. We will use this to define some kind of property for my unambiguous array. So I will say that in unambiguous array, every element AI should be a multiple of every prime number p less than equal to I. So that is what I am claiming. So I am claiming that in an unambiguous array, every element AI should be a multiple of every prime number p that is less than equal to I. And to prove this, I can prove this using contradiction. So let's assume my array is unambiguous, but still there exists some element AI. So let's say my array is something like A1, A2, A3. Still there exists some element AI which is not a multiple of p. Let's say there exists some prime number p less than equal to I, and my AI is not multiple of p. AI is not multiple of p. As we are assuming that my array is unambiguous, the only possible removal sequence should be 1 1 1 of all ones, right? There should not be any more removal sequences, but I will prove to you that there exists one more possible removal sequence in this case, right? As I know, my AI is not a multiple of p, or you can also write this as my GCD of AI comma p is equal to 1, right? As AI is not a multiple of p, I can say that GCD of AI comma p is equal to 1, as p is a prime number, right? So what I will do is I will keep removing elements as my p is less than equal to I. So this is index 1, this is index 2, this is index 3. There will lie some index p here, and then we will be at index I. So what I will do is I will keep removing elements from the start. So I will remove A1, my AI will shift one index to the left. Then I will remove A2, and I will keep shifting elements until my AI is aligned with P, right? At some point my AI will reach P, right? Because P is less than equal to I. So if I keep removing elements from the start, at some point my element AI will be aligned with index P. So in the end I will have something like this. I will have my element AI and it will be aligned with index P. And as I know, my GCD of AI comma P is equal to 1, I can then remove element AI and then I can insert index P into my removal sequence. So my new removal sequence will look something like this. So this is my second removal sequence. This is my first removal sequence. As I am removing elements from the start, my sequence will be 1 1 1 1 1, right? And then at some point my AI will be aligned with P. Then I will insert P into my removal sequence, right? Then again I will again insert 1 1 1 1, right? So as you can see, my first removal sequence is different from my second removal sequence. So there are two different removal sequences. So our assumption that my array A was unambiguous was wrong, right? So the property that we said was true. In an unambiguous array, every element AI should be multiple of every prime number P that is less than equal to I, right? Using contradiction. So we have proved that observation 3 is true. So now the problem becomes easy enough. So now we just need to check the prime numbers that are less than or equal to I, and then find the specific value of AI that we can have, right? Now let's see how we can write the complete solution using this, right? So now let's move on to the solution. So if I have some element AI, what is the possible value that AI can have, right? First, the possible values that I can give to AI are 1, 2, 3, so on up to m, right? Because I have been allowed m values, so I can give all the values from 1 to m. But I have to find the values of AI that will make my array unambiguous. So how can I find that? So I will keep iterating from the left side, and I will find all the prime numbers p, and my AI will be multiple of all the prime numbers p. So I can say that my AI will be a multiple of all prime numbers p less than or equal to I, or you can say that my AI will be a multiple of product of all prime numbers less than or equal to I, right? So if I have to find the valid values of AI among these values, it will just be valid values of AI will just be m over product of all prime numbers less than or equal to I, right? So now the problem is easy enough, right? So we will start from length. So for length, starting from 1 to n, I will declare a final answer, right? So it will store the final answer. This is currently equal to 0. So my final answer is equal to answer for this length, right? Let's say answer of L. And how will I find answer of L? My answer of L is just answer of L minus 1, that is all the possible sequences of length L minus 1 into valid values for AN, right? Because I have A1, A2, A3, so on up to L, right? If I already know the possible combinations of my array up to index L minus 1, and if I have to find the possible combinations up to index L, then I just need to find the valid values of this AL and multiply it with the previous combinations, right? So my answer of L is just answer of L minus 1 into valid values for AL. And how do I find the valid values of AL? I have shown here. So it is just m over the product of all prime numbers less than or equal to I. So I can say my valid values of AL are just how much? This is just equal to valid values of AL into, sorry, valid values of AL just equal to m over product of all primes less than or equal to L. And as we are iterating from 1 to n, we can easily find this while we are iterating from 1 to n, right? So that will be the entire answer. So in the end, your answer will be how much? Your answer will be just total minus final answer. And your total is how much? It is just m into m the power n minus 1 over m minus 1 minus final answer, right? So that will be the entire problem, and here it will be final answer is equal to answer plus final answer, right? Because you have to find for every length from 1 to n. So that will be the entire solution. And if you guys have to see the code for this, sorry, yeah, here is the code. So I will find the total value, that is just m into m the power n into m minus 1. So basically I'm just finding this value, right? So I'm just finding m into m the power n minus 1 over m minus 1. And I'm using mod, so keep care of that. Use mod properly, otherwise you will get wrong answer for large values. Then I will start iterating from 1 to n. And if my SPF of I is equal to I, that is if my I is a prime number, then I will multiply it into the primes that I already have, and if it is more than m, that is there are no more multiples left to use, then I can just break out, right? Because iterating anymore is useless, so I can just break out. So this is the number of multiples that I can have. The number of multiples that I can have is this one, that is m over the prod of primes less than equal to l, right? So this is m over the prod of primes. Again I'm using mod, then answer into equal to can have, that is the valid values of al, that is here. My answer of l is equal to answer of l minus 1 into the valid values that I can find. So here I found the valid values, right? Then I multiplied it into answer, then I can say final answer plus equal to answer. So first I found this, then I found this, and then I found this. Final answer is equal to answer of L plus final answer. And in the end, my answer is total minus final answer. And I'm using 5 mod because final answer can be negative. So total minus answer can sometimes get negative. So to counter that, I am adding some positive value here. So in the end, my answer will be total minus final answer, and I will mod that as well. And that will be the entire code. So if you guys have some doubts, feel free to join my Discord server. I will be more than happy to answer your doubts there. And don't forget to like my LinkedIn post, and I will see you guys in the next one. Bye bye.